Ollama just hit 112 tokens per second on Apple Silicon, nearly twice what LM Studio does on the same chip, and that gap could cut your inference wait time in half. If you're running models locally all day, that's real time back. Local AI tooling is moving fast in 2026, so I'm putting Ollama, LM Studio, and OmniRoute through 5 head-to-head tests to find out who actually wins. And the tool that wins on speed doesn't always win on deployment, so stick around, because the final test is the one that decides what you actually install. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. Every number in this video traces back to model cards, vendor documentation, or community benchmark runs. Both companies will actually stand behind. This one is for developers and tinkerers running 7B to 32B models locally, where the wrong pick costs you speed, money, or both. Test 1 is cost. The number that gets people is this. OmniRoute has 0 public pricing. You can't find a single published figure for what it charges. So if you're trying to budget an AI workflow before you commit, you're flying blind with one of these 3 tools. And that's a real problem before you sign anything. I looked at every pricing page all 3 tools publish, and here's what I got. Ollama and LM Studio are both completely free for local use, $0. Ollama's cloud tiers run $0, $20 a month, or $100 a month, and those are fixed vendor-published numbers. LM Studio goes pay-as-you-go per token, so for something like Kimi K3, you're looking at $3 input and $15 output per million tokens. OmniRoute, I couldn't find a single published rate anywhere. Okay, so the local cost is genuinely the same for Ollama and LM Studio, both free, and that's real parity. The moment you move to cloud though, Ollama wins on transparency because you know exactly what you're paying before you start. LM Studio's per token model can work out cheaper or more expensive, depending on usage, but at least you can do the math. With OmniRoute, you can't do the math at all. Cost is a tie on the local side, which is pretty much what I expected. Both tools are free to run. The cloud story is different though, and Ollama's fixed tiers are way more predictable than anything else here. OmniRoute's opacity is a real strike against it. Score stays at 0-0 with one tied, and we move on. Test 2 is coding benchmark performance. Think about what happens when you pick the wrong local model for a coding task, and your agent starts hallucinating function, signatures, mid-refactor. That's not a hypothetical. That's what happens when your tool's model ecosystem is thin. The question here is whether Ollama's coding models can actually get close to GPT-4o quality, and whether LM Studio's benchmarking tool gives you any real signal. The community data on Ollama's coding models genuinely caught my attention. Models like QN2.Valve Coder 32B and DevStraw Small 24B are reportedly hitting 70 to 80% of GPT-4o parity on everyday coding tasks when you're running on a 24GB GPU. That's community reported, not a controlled lab test, so I take it with a grain of salt. LM Studio ships a built-in benchmarking tool with a leaderboard, which is genuinely useful, but I couldn't find comparable published scores from them. Ollama takes coding benchmark performance. LM Studio's built-in benchmark tool is nice, but Ollama's model ecosystem just has more published signal, even if it's community sourced. Tooling without scores doesn't win a benchmark test. Ollama goes up 1, LM Studio stays at 0, 1 test tied. Test 3 is speed. The number that kicked this whole video off, 112 tokens per second. That's what Ollama's MLX backend hits on an M4 Max. If you're running long coding sessions or chaining agent calls, closing that gap from 58 up to 112 is the difference between waiting on your tool and your tool waiting on you. This one matters a lot if you're on Apple Silicon. I looked at the speed data across hardware setups, and the picture splits by chip. On an M4 Max, Ollama's MLX backend clocks 112 TOCs versus roughly 58 for LM Studio on the same machine. That's about 93% faster, and it's verified. On NVIDIA, the story flips. Community tests put LM Studio at 108.5 TOC-s on an RTX 4090, while Ollama on that same card runs 10 to 20% slower. On identical Ollama.cpp engines, they're basically the same. The caveat here is that these are different hardware setups, so you can't directly stack those two numbers against each other. But the split is real and it's consistent. Ollama wins on Apple Silicon. LM Studio edges it out on NVIDIA. If you're on a Mac, Ollama is the faster tool. If you're on a Windows machine with a high-end GPU, LM Studio is probably the call. The overall speed win goes to Ollama because Apple Silicon is where most of this audience is running local models. Ollama takes speed. The NVIDIA numbers muddy things a bit, but the gap on Mac hardware is just too big to ignore, almost twice as fast on the chip most local AI users are running right now. Ollama moves to 2 wins, LM Studio still at 0, 1 tied. Alright, so Ollama is ahead right now, but the next 2 tests are context limits and deployment. And deployment especially is where the whole picture can shift. If LM Studio's headless mode, which only launched in January 2026, is actually good enough for server use, it changes the recommendation for a lot of you. Don't skip the last test. Test 4 is context and output limits. Here's the scenario. You're feeding a 20,000 token codebase into your local model, and it just silently truncates halfway through. You don't get an error, you get a hallucination, and you don't find out until the output is wrong. Knowing how much context you can actually control and whether you can adjust it without touching a config file matters more than most people think. I looked at how each tool handles context, and here's what I found. LM Studio gives you GUI sliders to set context length directly, which is genuinely easy and doesn't require any CLI flags. Ollama relies on model defaults or you pass flags at runtime. For cloud, Ollama publishes that sessions reset every 5 hours, which is at least transparent. LM Studio has no cloud usage limits for local models. OmniRoute, I couldn't find any published figures on context limits at all. Context limits is a tie. Ollama's transparency on session limits is useful, but LM Studio's slider control is a real advantage for non-technical users, and neither tool publishes a hard token cap for local inference. Both sides win something different here. Score stays at Ollama 2, LM Studio 0, 2 tests tied. Test 5, the last one, deployment and modality. If you're wiring a local model into an app or a pipeline, and the tool you picked doesn't expose a clean REST API, you're rewriting your integration from scratch. That's not a small problem. Ollama has had a native headless mode and an OpenAI compatible API for a long time. LM Studio only added headless mode in January 2026. That gap in time matters for production reliability. I went through the deployment specs for all 3, and the gap is pretty clear. Ollama is MIT licensed, runs headless natively, exposes an OpenAI compatible REST API, and has over 40,000 community integrations. LM Studio added headless mode this year, has Python and TypeScript SDKs, but it's closed source. OmniRoute is a cloud gateway, not a local runner at all, so it's playing a different game entirely. For server deployments, Ollama is the only one that's been production ready for a while. Ollama wins deployment. I went in thinking LM Studio's new headless mode might close the gap enough to tie this one, but MIT licensing plus 40,000 integrations, plus a native REST API is just a different tier of deployment readiness. Ollama finishes at 3 wins, LM Studio at 0, 2 tests tied. Ollama wins when you need to deploy. It's MIT licensed, headless out of the box, and it runs an OpenAI compatible REST API that plugs into over 40,000 Compa community integrations. Its MLX backend hits 112 ToK-S on an M4 Max, which is about 93% faster than Llama.cpp. Cloud pricing is fixed and published. Free, $20 a month or $100 a month, no surprises. LM Studio wins when you want to explore models without touching a terminal. The GUI is polished, the model browser is built in, and you can tweak context length with a slider instead of a CLI flag. On NVIDIA hardware, community tests put it at 108.5 ToK-S on an RTX 4090, which beats Ollama on that chip. The built-in benchmarking tool with a leaderboard is also a real differentiator for people who want to compare models quickly. OmniRoute wins when you need a managed cloud gateway and you don't want to deal with local hardware at all. It orchestrates across multiple models and providers from a single API, which neither Ollama nor LM Studio does natively. No GPU required, as scales on demand. The catch is, there's no public pricing, so demand a quote before you commit to anything. It's a different layer entirely, not a local runner. For most people, Ollama is the pick. 3 wins, 0 losses, and that MLX speed advantage on Mac hardware keeps coming back as the number that matters. I thought LM Studio's GUI and its new headless mode would make this closer, but the deployment gap and the open source licensing just aren't close. Go LM Studio only if you're on NVIDIA and you want a GUI first experience with no CLI. Go OmniRoute only if you need cloud orchestration and you're okay with opaque pricing. If you're trying to figure out which coding agent to pair with your local setup, I did a full breakdown called Kimi Code versus Codex. Which cheap agent wins? It's the same format, same rigor, and it answers the question of which agent actually gets work done without burning through your budget. That one's worth watching next.